Hi everyone, really happy to be with you on this new webinar for SC21, the incessant pursuit in the exascale journey. So the agenda for today is the following. Cannot change. Okay, sorry for this. So the agenda for today, I'm happy to share the stage with Jean-Pierre, with Steve, and with Cedric. And you can see we're going to cover a lot of different subjects today. And I will start with just the highlights of this year. That's exactly, to start with. Okay, it looks like I have some problems. So just the achievements and the major highlights. Again, we've consolidating all our worldwide presence, and we did new sales in new countries, new areas on the planet, and that was really good for us, starting with Korea, with KSA, with Colombia, and significant growth in Brazil. Always big presence in Europe, for sure. A few touch points elsewhere, but really on our path to growing our business and disseminating our technology and seeing all our customers. We are making a lot of progress there. A very important achievement this year was the Nimbix acquisitions, and this is towards hybridization that we want to implement in our over our portfolio. This has been a great input to what we have in different areas. First, with unique IP that we are bringing it with our software that is coming from Nimbix, and you'll get a lot of details later on, but also with this presence in the US, which is for us really something additional to what we've been doing in terms of sales coverage. Another very important point, and it has been always very key for us to be very strong in managing with our technology partners. So the traditional one that we have in that landscape, but really making good progress with these guys. And I'm thinking about AMD, Intel, Nvidia, Cyber, in the area of compute power, but we are also having great success and great work being done, let's say, in the quantum computing aspects, with a very good partnership with IQM, with Pascal. We also have very strong partnership being done with Megazone, with Graphcore, and it is more on the reseller, but also the partnership with Graphcore and on top of Nvidia in this AI business. On the storage, we are having, of course, DDN as a primary partner for our storage solution, but also developing a lot in the future with base data. And very important as well to mention, strong partnership being developed by the team and for future sales with hyperscalers, and I want to mention two of them, not being the exclusive of our work, but with Google and OVH. So this is absolutely something that is kept on top of our priority. And what I would like, of course, to highlight is the new ranking of the top 500. We've been putting more than 15 systems since 1 year, which is enormous. This is the result of many sales that we had in the last years. The latest one, significant one, is the CE entry with Exa1 machine, and we are highlighting the PXI V2 interconnect developed by Atos, as well because it first entries and still Euro HPC installations and much more. I'm thinking about other installation that we did in the last year. So very important breakthrough in this, and yeah, just to highlight these, some interesting installation that you have. Of course, not everything being yet into production, and especially the Chineke machine, which is the next very big system that we're going to deploy, being really in the supply path at the moment, and the Decalium machine in Portugal also on the path to be delivered, but most of the others have been installed and have started getting users for research and available for the rest of the company. On the road to Exascale, still the same pillars, and we'll go into this in the next slides. Sequana, this generation and the next to come, the Atos QLM, enhancing also all the software environments, and being agnostic in terms of hardware for the future, but developing a lot and giving access to the MyQLM in the future. DXi Interconnect, as I just spoke about, the V2 is on here, is absolutely giving the right result on the one that we were expecting. Still progress to make, of course, on the long run to improve for application workflows, but it is already at a very high level for applications throughput. Already thinking about the next gen. And Xtor is going on here with some new first sales that have come this year. All this being orchestrated in the HPC environment for Exascale with our smart management suite, all managed through Kubernetes. So the new stack is available, is being deployed at the KLZ system as the first implementation, and much more, and will be definitely the standard for the future. Last but not least, our next mission, of course, is to continue that journey to make and to develop the best innovative and energy efficient solutions for on-prem and cloud-based solutions. And this is to the full addressable stack of HPC, of AI, and quantum customer needs. We want to expand this hybridization for the future. We want to give access and to help on the application workflow to enlarge these workflows, and to be able really to take the best advantage of each technology. Of course, decarbonization is a very big ambition for Atos Group. It is also for HPC environments. Definitely, we are looking at all stages of the what we produce to give access to the future to our customers. So from producing, engineering, developing, delivering, and of course giving access at customer side. This is the top priority for us in the next years. Now I'm gonna hand over to Jean-Pierre, and he will be able to give you, of course, more details on these aspects.
Thank you, Agnès. Hello, everyone. So I'm really excited about talking a little bit about what we're doing for Exascale and how we plan to tackle these Exascale challenges that have been with us for quite a while. If we just have a quick overview of where we've been, it's been a long ride towards Exascale. I mean, and I think at the moment we have all the almost all the pieces in hands to really be able to tackle these challenges. The goal, if you remember, that was set to us quite a few years ago when we started talking and planning for Exascale was, of course, to reach the exaflop, but there were some constraint and condition attached to that. It was something that is quite, it's still quite challenging, is to be able to deliver that amount of performance in a 20 megawatt envelope, and this by originally we thought it would be available by 2020. COVID has been the COVID pandemic has been through that and didn't help reach that goal, but it would have been difficult, and still, we're still waiting for a top system on the top 500 which has that amount. Even though there are some rumors it's been achieved, but probably not with the envelope that we set for power consumption. So but most importantly, I mean, what was seeked is the improvement factor on the HPC application, and really a factor of 1,000, 3 orders of magnitude with respect to what was available at the time. There's one thing that was very clear from the beginning of this journey is that with the end of Moore's law, there was a place that would be predominant for accelerators. They were expected to play a central role in Exascale. So this is something that we see more. And I was saying, it's at ends reach. I mean, now we're getting close to it. We know we have a very good sense of what the technology will be available to reach its goal. There are some twists with respect to the original ideas of what it could be, but I mean, I think it's there. A little more details now. When we were looking at this Exascale, I mean, it's the purpose is really to meet the ever-growing HPC requirements, HPC application requirements. And this goes, with the use of much larger data sets, using more parameters for more realistic simulations. Also in the data management, I mean, there were more and more data, and this is actually exploding even faster than the computing requirements. Also, another thing that is very important is the fact that with respect to classical HPC, now we have to integrate, in a continuum of computing from the edge sometimes, and so this involves, for example, when we consider the digital twins, the input of live data. Obviously, much more computing, which involves, higher level of parallelism, which is a challenge in itself. The use of new computing elements like GPUs, FPGAs, or other AI-dedicated specialized systems, and sometimes in the near future or midterm future, quantum computing. Now we're still with this envelope of 20 megawatts. I think this is the reasonable maximum that I see for most of our customers in Europe and around the world. There are some exceptions, very large systems that have been deployed that go up to 30 megawatts, but it's beyond the original envelope, and still, I think it's going to be a challenge for many of our customers. So we try to stick with it. As I was mentioning, accelerators and in general, heterogeneous computing is really something that comes into play when we're looking at Exascale. Exascale, it's really a prime time for GPUs. And on the left, you have a picture of the Nvidia A100 Ampere GPU, and this is what is fueling the performance of the system that was installed at the Jülich Supercomputing Center in Germany, the booster partition, which is ranked number 8 on the top 500. It's been installed and it's been up and running for more than a year now. In the middle, another type of GPU just announced, the AMD MI200 series. We'll be supporting this in our Bulls-Sequana X400 series, and looking forward to the next generations as well for our IN systems. And on the right, this system, sorry, there's a little glitch here. On the right, we have the Intel Ponte Vecchio, which is a system that will be integrated in Bulls-Sequana XH2000, 3000 when it's available. So these are the GPUs that we see today that will be supporting, and that these and their next generation of these different GPUs will be what we'll be using for our Exascale systems. Now, there is also new technologies that we are looking at and that will play a role, and more generally said for some specialized workflows. Have in mind, the FPGAs which are performing very well for some pattern matching and gene sequencing type of analysis, for example, but also some new neuromorphic architectures that are being developed, and also eventually quantum computing when it's available. With all of these technologies, I mean, this is one big part, but you don't have to forget about the classical CPUs and the general purpose processors that have still being used, and we foresee that will still be used in the coming years in large HPC systems for the exascale era and even beyond. One example of large systems, HPC systems, is this new system that was installed at CEA in France called EXA-1, and this is currently number 14 in the top 500 list. It's not in the top 10 because it's using only CPUs, so it doesn't rank that high in terms of flops, 23 petaflops. But it's really amazing in terms of the performance that it delivers for general computing, and it's featuring more than almost 13,000 AMD CPUs. That's if you do the math, it's somewhere around more than 800,000 cores. So it's a very high level of parallelism, and it's really a workhorse for your HPC application. This obviously could be completed with the kind of accelerators that we mentioned before, GPUs and so on. But I mean, something that we don't want to forget in a picture for the exascale is the use of CPUs. And so beyond what we have available today, we're looking at the next generation of Intel. So the code name is Sapphire Rapids, and you have a picture of something that was announced just a few days ago, Sapphire Rapids, and there will be an option for HBM, fast memory on the CPU. There is also in the pipe coming the next generation of AMD CPUs, code name Genoa. We're also expecting to be able to use the HyperHub CPU that is developed under the API, European Project European Processor Initiative, which is developing a new processor based on the ARM architecture. So this is something that is coming and that will be making available to you for your exascale systems. The one thing that I already mentioned, about when we talk about exascale is really the large parallelism that is required with the thousands, hundreds of thousands, millions of threads that are and the cores that are available in this exascale system. And all of this has to be interconnected and really efficiently interconnected. So obviously we had this longer experience with InfiniBand. Currently we're deploying systems with HDR, that's 200 gigabit, or HDR 100. In the coming months, years, we'll probably have NDR available, that's 400 gigabit. But also, I mean, something that we've developed and it's performing quite well, as it's been demonstrated on the EXA-1 system, is the interconnect system that we've developed was named Dual Exascale Interconnect, DXI. So this is a second version, which is really targeting, it's a general purpose interconnect. It's not as specialized as the previous one, which was really dedicated to the many core architecture. But this one is available for all kinds of CPUs, all kinds of GPUs, nodes, and accelerators. So it's really something that is important and that will be we'll keep moving on and executing and preparing for the next generation as well for the exascale, being able to meet that challenges in terms of scaling very large systems. The last point I want to make, and this is interesting that you had the last week news were full of the COP26, the conference and discussion, and all this, and really it's something that is getting really high in people's agenda, is the fact that we need to take care and to work better towards a greener world, and for us, for the HPC world, mean green computing. So this is just a reminder of what the Dulce-Guana XH2000 is today. I mean, this is really, as you see, you have the front and the rear pictures here. It's really in terms of the amount of power, computing power that is available, the 32 blades, or the power that is delivered to the system with power supplies here up to 90 kilowatt for this for a single rack. But also what goes with it is the cooling. And why is the cooling? This cooling is important, and what's so specific about the Vultr Sequana is that we can cool it with warm water that is at the input level and the data center at temperatures that can be as high as 40 degrees Celsius. So that's more than 100 Fahrenheit for the Americans. But what it means is that with this high level of temperature, we don't need to have chillers in the system. So really, we save up to 40% on your electricity bill, and as it's a good contribution to make our world a little greener with using less energy for this. The PUE is less than 105, meaning that the cooling cooling requirement for cooling is less than 5% of what is used in the system itself. So it's pretty good, and with the high temperature, it makes it this is a quite unique solution in the industry. This is our already third generation. As you can imagine, we are preparing a fourth generation, which will go even beyond what it can do today. Just another thing, which is actually something that it's not linked to Exascale itself, but it's very important when you want to deliver this, in the sense that most of the time your data center, which was maybe built a few years ago or decades ago, is not able to handle easily this size system and all the requirements in terms of the specification that we are required. So there's one thing that we start doing, and we have more than I would say probably a couple of dozens of already implementation like this, is delivering a modular data center. And you see these modules here, where when we were installing a system that will be inaugurated in the coming weeks, which is a 20 megawatt data center. So it's really something that is very convenient for the customers. I mean, in terms of it's reducing the cost drastically with respect to concrete building. Also, it's enables much faster deliveries, and for medium-sized system, it could be 6 months. If you have a 20 megawatt system, I mean, you probably need to take to plan for this a little in advance, more in advance. But it's really something that it's much more convenient and much more flexible in terms of a solution than building planning for a complete new building. So this is just a complete picture of a few elements that are key to solving the challenges for Exascale. Just as a recap, again, we see this wide use of accelerators, and specifically right now GPUs, but it's we have growing numbers of solutions there, and beyond CPUs, other like FPGAs that can be available. The CPUs is something that is still will be with us and very important for the Exascale. We really need when we look at the systems, I mean, this high level of parallelism is calling for high performance interconnect. There are some solutions that are available out there that we're also developing our own. So you remember the green computing challenge is something that we are partly tackling right now with direct liquid cooling. There is more to come in being able to feed our data centers with green energy itself. And this modular data centers that is really enables you to have a much more flexible implementation for your in-premises systems. Now, there are a couple of things that I didn't have time to touch on today that has to do with data management, which is quite important, was mentioning before, and the whole software environment. I think this is something that we could go into more details if you're interested. But when we look back, there are a couple of things that were not really well foreseen at the time when we started this Exascale journey. And for example, I mean, the importance of AI was something that people were not anticipating. We didn't think that AI, which the first implementation or usage was for image processing or image recognition or natural language, would have such an impact on HPC. And my colleague Cedric will give you more detail on this. but also the fact that we'd be using this high level of hybrid computing and being able to use the cloud for HPC. And this is where my colleague Steve Ever from a company that we acquired called Nimbix and now part of Atos will give you more details on. So with this, Steve, it's up to you to give us more detail on this cloud. Thank you.
All right. Thank you very much. It's great to be here live with my colleagues in the very beginning of the Exascale era. And as we talk about Exascale and the actual systems that Jean-Pierre just talked about, there's another vector that's really important, and that is making HPC available to more people. Not everyone has the ability to deploy a 20 megawatt exascale system to do their HPC and to do their science, but many people and industries around the world have huge demands for computing requirements. And this is where HPC cloud and HPC as a service comes into play. And I'll talk a little bit more about what Nimbix is bringing to the Atos portfolio. Many of you know Nimbix as a pioneer in HPC and heterogeneous accelerated cloud computing, and we're going to talk a little bit more about that. And we also have some sessions throughout the SC conference where you can go a little bit deeper in those domains. So first, let me introduce a few of the HPC offerings that Nimbix brings to the Atos portfolio that gives organizations and our customers the ability to have flexible models for consuming high performance computing. And the first is what has historically been the Nimbix Cloud offering, or Nimbix Cloud Everywhere. And we say everywhere because we have given customers the ability to consume this on any cloud, any native compute endpoint, whether that is on-prem or consuming it in the cloud. And this is truly a turnkey as a service offering where there's nothing to install, nothing to deploy. Customers log into the cloud with point and click workflows, specifically catering to domain engineers, scientific experts, and the benefits here are really getting started very quickly. But as we go forward and we look at the technology that powers these types of hybrid and cloud environments, Nimbix also offers Jarvis Xe along with the App Store, which I'll talk about in a little bit more detail, HyperHub. And this is the leading container native hybrid and multi-cloud HPC platform that can deploy on next generation exascale systems on-prem, but also seamlessly extend these same workflows, these same high performance codes into any compute endpoint, including hyperscale clouds. And this product is a software platform that can be deployed by enterprises, universities, service providers, academia, and so forth, any consumers of HPC that wish to really modernize the HPC deployment methodologies and scaling those across all compute environments. And the other key benefits of this is to give the end user control of the actual platform. You're not necessarily configuring to one specific cloud or one specific on-prem machine. It actually gives you a global landscape and control with both your applications, your users, your workflows, with all of the different compute endpoints. And then finally, one of the components that's really important for Jarvis Xe is what we call Cloud Pak. This is really an endpoint that can deploy on any compute or Kubernetes powered infrastructure. It's compatible with every major hyperscale cloud provider, but also can be deployed on any, again, native Kubernetes endpoint. It could be a remote data center in organizations that have many supercomputers, for example, where you want to federate those machines globally. And again, this is for organizations that have existing infrastructure that want to deploy and make pervasive use of that infrastructure, but also extend the compute capability outside of the four walls of those machines. And then ultimately for the Cloud Pak, there's virtually nothing to configure, and it deploys in a very self-service way, and then is fully managed by the control plane upstream. So a little bit more about Jarvis Xe, which is can be deployed really as a public cloud endpoint, a private cloud, or a hybrid of both of those, and any combinations of those, whether they're, again, it could be a hybridization of a federated set of supercomputers around the world. It could be federation of different data centers that are private to a given organization. But also importantly, it enables customers to seamlessly adopt and consume available public cloud resources and all of the HPC components that are being deployed in those clouds. And really the goal of Jarvis Xe is to do a couple of things. One is to simplify dramatically the user experience for HPC. It makes it truly a modern app store experience like you would on your mobile phone, but for very high performance, even MPI, large scale traditional HPC applications. Importantly, it also simplifies HPC for the administrators and the enterprise IT organizations that have to maintain uptime on these environments so that the domain experts can continue to access compute resources when they need them. And I think another important thing, in addition to simplifying experiences, we want to do this without sacrificing performance. And one thing that we've learned in many ways is sometimes ease of use means we have to actually reduce performance to get the ease of use. And one of the beauties of the Jarvis Xe platform is it was designed from the ground up to be basically hardware native, silicon native. So taking advantage and delivering to the modern HPC applications all of the performance of the GPUs that Jean-Pierre mentioned, the FPGAs, the next gen CPUs. We want to expose those capabilities to the application unencumbered by any software stack that would sacrifice that performance. So the other element that's again become much more pervasive in HPC that Nimbix has been pioneering for many years is it's a fully container native platform that enables applications to be managed, deployed, maintained, and distributed globally in containers with a built-in platform as a service feature. Now, this is important in the Exascale era because many of these codes are very large-scale codes that are compiled for a given machine. And then the question becomes, well, how do I put that in a container? And that's exactly what this platform was designed to do, and be able to spray those containers across your large-scale machines without sacrificing any of the performance. And then ultimately leading to reduced complexity in the landscape of computing for hybrid cloud and HPC, and also lowering the cost per answer that we're all seeking to do. Both in, Jean-Pierre talked about lowering power. We also want to lower the cost of the compute so that we can generate more answers at an ever faster rate. Okay, I'm just waiting to slide advance. There we go. So when we talk about HPC as a service implies that we need apps. HPC, a machine is useful insofar as it deploys an application that actually transforms data or processes data or computes on data to deliver a result. And part of the Nimbix portfolio is an application marketplace we call HyperHub. We call it HyperHub because it transcends not any one architecture for computing. It enables GPU-powered or accelerated applications, FPGA accelerated applications, different CPU architectures where codes have been optimized. And all of these are in a containerized application marketplace that we call HyperHub. And this is important because in the as-a-service model, you want to be able to propagate your curated apps and workflows irregardless of where you run them, whether they're running in a downstream cluster in a cloud provider in Western region in the United States with an on-prem supercomputer that sits maybe in a different region of the world, and enable the deployment of these applications seamlessly across those different endpoints. One great example of this is in the cases where you have codes that are taking advantage of ARM64 architecture or the latest x86 architectures. There are cloud endpoints that offer these types of resources that can complement the on-prem machines. So this is a great capability that comes packaged with Jarvis Xe. and includes that native accelerator support. The other thing that it enables that I think is really important from an economics and as a service option is built-in support for auto scaling on the cloud. So there's no need to build or architect specific scaffolding to be able to scale the compute. Literally, it scales based on the job that's submitted to that endpoint and configures the infrastructure around the application and workflow. So very important capabilities for the as-a-service model. So Nimbix and Atos are delivering broad industry support across all the major industries that require HPC or do that as part of their day-to-day domain expertise and domain science with, again, as I mentioned, applications that are ready to run and fully deployable on these diverse compute endpoints. And allowing, again, flexibility in the consumption model for customers that need rapid access to computing horsepower. And finally, the primary benefits are really about, as Jean-Pierre mentioned, hybridization in the exascale era is taking the ability, the highest performing capability machines and blending those with other available resources that might be targeted and specific for various workflows. So truly enabling an optimization of the on-prem system sizes for maximum utilization while handling variable capacity or specific peak workload activities off of that primary resource. So this gives instant flexible burst strategy with support for every major public cloud out of the box. So immediate capability to deploy either in a Nimbix managed tenancy or your customer owned tenancy with where you may already have agreements in place with various cloud providers. The other benefits are with the as-a-service approach is global user, job, machine, application management. It's fully transparent across your entire computing landscape globally. And then, of course, also a nice benefit is being able to test new hardware capabilities that come online, whether it's in on-prem machines or also available in various clouds. So with that, I think that was brings us to our next section, where Cedric's going to talk more about the AI portions of the portfolio and hand it over to you, Cedric.
Thank you, Steve. It's a pleasure to welcome you in this SC webinar. So just to go back on the message from Jean-Pierre on hybridization in the Exascale area, I will deep dive into the AI part of hybridization. So this year we have put in place a dedicated approach called Atos ThinkAI, and everything started by this statement on the convergence between our HPC challenge and HPC roadmap and the AI evolution. And as you can see on this graphic, we are seeing today in the computer area a big demand for AI capacity, AI training capabilities. The evolution is tremendous, exponential in terms of computing, and each and every year we are seeing new model, new needs for bringing all our expertise in HPC and in Exascale architecture to the AI domain. So based on this statement, to be able to bring Exascale level system for AI, we have decided to bring to the market the Atos ThinkAI offering. So what is Atos ThinkAI? It's a complete approach, complete portfolio of expertise, consulting, capabilities to understand the data science on a specific verticals for industries, but also to work on state-of-the-art of AI research for the academia. First, the second part of Atos ThinkAI is to be able to architecture the best of breed of technology to enhance AI thanks to high performance computing. So for this, we have of course all the Atos portfolio capabilities, but we are bringing specific AI technology, AI compute technology, like Graphcore that has been mentioned by Agnès. So the objective is to bring and to architect best of breed of hardware, software ecosystem, because it's key for a kind of dedicated AI infrastructure to have the good data science environment to be able to use efficiently this kind of HPC system. Also, as part of ThinkAI, I will explain what we are doing also for the AI into the simulation world. So, of course, we are bringing our HPC expertise for the AI domain, but we are also developing specific AI models, workflow, and capabilities for science application and for numerical simulation. For example, on weather forecast or on CFD application, we dedicate software development on this. Security is one of the major concern of what we when we have a shared AI infrastructure, and what has been presented by Steve is also one of the key assets we can use to do on-prem cloud AI with a big HPC system. So bringing the capabilities to have a multi-tenant, secure on-prem system to be able to share between industries or SMEs, dedicate AI resources is one of the key assets we have thanks to our digital security consulting and product. And of course, being able to smoothly deliver, put this kind of dedicated AI infrastructure in operation for a customer. Of course, when it's in research center, people are used to manage such large-scale system, but in some industries, it's brand new supercomputing system, and it's one of the key added value of Atos to bring managed services, to bring knowledge transfer to manage exascale class of supercomputer to industries. So scalability and operational excellence is part of the Atos ThinkAI portfolio as well. So as mentioned, we have all the Atos product portfolio capability with Bulsicona XH, what we have delivered in the past years with, for example, the booster system. So we have top high-end HPC capabilities with GPU that can be used for AI. But as part of ThinkAI, we have also introduced other capabilities, like the one with Nvidia GGX Superpod. So basically, the objective is to bring to the world this smooth integration of DGX capabilities for enterprise company and for industry. So being able to build dedicated AI supercomputer with the integration of Nvidia DGX appliance, which makes this more accessible to the enterprise market for data center reason. And we are one of the leading partners of Nvidia in this business today in the world. We have delivered many Superpod in the past. We started with the University of Oxford in the past, where we built the first DGX-1 Superpod. And we have continued this work with key research center like CDAC in India, where we have delivered last year a Superpod for the AI research in India. We have delivered this year the University of Linköping and the WASP project, which is also a research focus to bring the Sweden AI research ecosystem to a dedicated supercomputer for AI. So that's the three main research centers we have worked in the past on Superpod. We also have enterprise company which are today developing application with Superpod, like Telconet in Ecuador, where we are developing smart city application. So dedicate AI model for smart city, and we are putting this in operation thanks to a Superpod. So we have this kind of different research, but also industries capabilities to bring AI supercomputer for them. We have new projects in finance, in healthcare that are very suitable for this kind of infrastructure. The second part, to continue in more advanced dedicated solution for AI, is the benefit of we have integrated Graphcore as part of the Atos ThinkAI brand and solution. So Graphcore is a strategic European partner for Atos for the AI hardware acceleration. So we have worked during almost 3 years with Graphcore to bring their solution and in our portfolio, be able to build Graphcore pods, be able to deliver and to work with our customer at the application level. So we were the first company to build in our factory what we call an IPU pod 64, which is a full rack of Graphcore IPU that is used today for NLP type of application in internet services provider in APAC region. And we have just announced some weeks ago the IPU 128 and 256 that are available today in our portfolio. We are able to deliver and to build this in our factory. This kind of configuration are bringing more scaling, can be smoothly integrated into a standard HPC configuration. So we know how to integrate through the storage or the interconnect the Graphcore technology inside kind of Bull-XH environment. So those new configuration in terms of AI bring very good throughput, very good performance, and they are one of the good company to bring really hardware that are suitable for AI. And as we are seeing more and more AI in the evolution of the research, but also the industry, it makes more and more sense for our customer to explore Graphcore technology and to invest in dedicated AI technology. The last point I'd like to mention today is what we are doing today in terms of application, because as part of ThinkAI, we have the hardware, the software, and the people, and we are working on the science part. So we have built a center of excellence in weather and climate modeling in collaboration with the ECMWF. And in fact, today we have a dedicated track of working on using AI for weather forecast. So we are working not on the infrastructure part, we are working on the data science part, or we can explore, develop deep learning model for example, the emulation of the parameterization scheme in weather forecast. So that's something we have started to work on last year. We were part of the ECMWF workshop where we presented where we are in terms of research. So it's a very low TRL development today. The second part, which is key, is also on the application, or we can work on machine learning model that are able to represent a part of the atmosphere. So that's also some physically informed neural network we are exploring with them. Working on the pre-processing of the data, working on the post-processing of the data with AI is also key for weather forecast, as we have a lot of data input and output, and AI is really key to optimize the workflow globally, not only the numerical simulation part, but the full workflow. So we also have as one of the key objectives of our Center of Excellence to develop specific feature extraction with AI instead of using manually with the people in ECMWF. And as our an industrial, we are also bringing what we call the exploitation part, so the coupling between the pure AI and pure data science work into a production system, because it's good to explore model, but once we will know that those models will be suitable for production, we need to bring this into production smoothly. And there is a lot of software development that needs to be done and standardized on how we couple a numerical simulation application and an AI-based model. And that's also part of the development today we are bringing to the Center of Excellence to explore what are the good way to couple this through MPI, through other languages. So that's also a big axis of development that is today the same for each science application and each workload. We are all looking today in CFD, in weather forecast, in chemistry, how we manage the full workflow in pre-processing, post-processing, the numerical simulation part, and the way we bring this into an Exascale production system. So that's one of the key strategic acts of development of Atos in the AI for simulation R&D program we have today. I think it was all for the AI part. So Agnès, I hand over back to you and all the team.
Thank you very much, Cedric. And we are all back online with you. I think maybe Laurence, do we have any questions from the audience?
Yes, we do. Hello to everybody and thank you for your participation. So first question actually, Cedric, about ThinkAI. The question is the following. Can we use the same ThinkAI environment for managing both HPC infrastructure and edge solutions?
That's a good question, indeed. Yes, we do. As part of the ThinkAI approach, we look at the software environment and software ecosystem. And today we have the capabilities both to use Slurm-based system and Kubernetes-based system. And with the same resource management, we can manage both a dedicated AI system based on Kubernetes and some edge server. We had a project we work on the design between Bull-Secona edge server we have in the Atos portfolio and a full pod of DGX. And from a software point of view and a data science point of view, we were able to manage both kind of configuration. So the answer is yes, we can.
Yes, we can. Thank you, Cedric. Okay, Steve, a couple of questions for you. How easy is it to install Jarvis Xe? And can it run on any HPC cluster? Can you give any specification on prerequisites?
Yes. So the answer is yes, it can run. The primary prerequisite is that it does rely on Kubernetes as the base foundation. It's very easy to install, and we have a lot of deployment automation scripts that are available on GitHub that can be used to actually deploy it. And actually, once Kubernetes is deployed, and more on that in just a second, it literally takes only just a few minutes to bring up the entire platform and then synchronize the core catalog of HyperHub along with, and then of course, if customers deploy and want to customize and tailor it, those are set up in configuration specific options. The Kubernetes elements are actually quite easy, especially if you're adapting to any of the clouds. They all have public Kubernetes services like EKS on Amazon, AKS on Microsoft, GKE on Google, OKE on Oracle, and these providers do a great job of enabling their HPC class resources within that construct. So you can actually bring up a compute endpoint in a matter of minutes on any of those clouds. There are some prerequisites for if you're deploying Kubernetes directly, and we have some guidelines published online that we're happy to follow up with there. And I think that should cover the main part of the question. There might have been, did I miss this part too?
No, that's fine. And then there was another question about do you also support other licensing models than bring your own license?
Yes, that's a great question because a lot of the applications that customers consume are from large ISVs that are oftentimes licensed separately. Generally, our position on licensing has been to provide flexibility for all of the different applications. So while I showed on one of the slides, bring your own license, because again, large ISVs like Siemens or Dassault or Ansys in the engineering domains have generally flex-based licensed management tools, and Jarvis plugs in seamlessly with those, or those plug into Jarvis really. We do support other licensing models natively where we can actually embed the license software into the workflow that's defined in HyperHub. And so we do have ISV partners that actually deploy in HyperHub and have more of a software as a service approach. And that also applies to in-house applications or algorithms that customers may want to actually price to do cost allocation. So very flexible on those models, and we do support all of the above.
Thank you, Steve. Just quick couple of questions for Jean-Pierre before we close. When does Atos plan to integrate the European processor from SciPearl? And in the same spirit or idea is, when will the AMD Genoa processors be available on the market in general and especially in Sequana systems?
Thank you. So yes, I mean, this is important. As I was mentioning, This is important for us to support, a variety of different solutions. So when it comes to Cyprel and their first chip, the first CPU that will be called for, codename Rhea, we are planning to support it into our Bull-Sequana XH2000 or the follow-up that will be liquid cooled. So it is the high end of our systems. The reason for that is that, well, it's nice to support European technology, but beyond that, there are some interesting features that make it interesting and could applicable to HPC workloads as a standalone CPU for CPU-only nodes, but also for heterogeneous modes in conjunction with accelerators, GPUs, or other type of accelerators. So yes, we are working on with Cyprel and make it available on our high-end systems. The second question regarding Genoa. So Genoa, the fourth generation of the Zen CPUs. The AMD CEO Lisa Su announced a few days ago that Genoa would, with 96 cores, so that's 50% more than currently, and using 5nm technology, will be available in 2022. So that is, quite challenging given the situation of a shortage of, the supply chain. But we are making our system ready, and we'll be hosting and deploying a system with Genoa as soon as available on the Bull-Sequana, the direct liquid cool high-end systems. So as soon as available, and that's 2022. With the exact date and months we'll be seeing. But we have been working on this, and we've been doing this for quite a few months already. So it's going to be ready.
Thank you, Jean-Pierre. Well, I guess we'll close the session, the question and answer session now, because we just have a couple of more minutes for Agnès for the closing words before we reach the end of our 1-hour session for webinar. Thank you.
Thank you, Laurence. Thank you to my colleagues for the speech. Again, I wish next year or in 6 months we can meet all together face to face. As usual, we are, as you can see, we are continuing our journey. If you look back to the last years, where we were extremely focused on the hardware for sure, but also, we started having this idea of the direct liquid cooling, and we are moving more and more with next generations with new technology. Same with the interconnect, same with the integration of accelerators, which we are seeing the big adoptions of the market. FPGA as well is part of our thinking for sure. We are really thinking every day on next steps, and we are committed for this green computing, decarbonization environment, finding the right hardware and software solutions to build our solutions. And this is our motto of every day. This is what we are trying to achieve with your input. So any inputs from you guys, customers, partners are important to make sure we are making the right choices. We cannot do everything. We're trying to do the best of what we can master. We are working closely and more closely with the customer. We want to work first on, as I said, green computing, as we call it. We want to work on the accessibility of the compute environment. So I'm thinking about all the software that we are developing for that, and this mixed cloud on-prem access. What we've been doing as move integrating Nimbix in our portfolio is in that landscape. Last but not least, applications we wanted to finish with Cedric, and specifically on the AI work around the weather forecast, but AI is everywhere, not only AI, but all our experts on application performance, and also getting this hybridization thinking for the future is absolutely key. We did not talk too much about quantum in that session, but this is still on top of our thinking for innovation in the future. You're going to see more news in the coming months around that. Again, we are always pleased to have dedicated sessions with you guys. So reach out to us. And thanks again for attending. Keep safe and talk to you soon. Thank you.
Thank you.